Our activity today deals with irrational numbers. What are irrational numbers? In mathematics, an irrational number is any real number that is not a rational number. Yes, it is a number which cannot be expressed as fraction a by b, where a and b are integers and b is not equal to 0. In other words, these numbers cannot be represented as simple fractions because the decimals go on forever without repeating. They are non-terminating or non-recurring decimals. Pi is an example of an irrational number. Do you know what the value of pi is? Well, here we go. Its value is 3.14159265535 and it goes on. Another example of an irrational number is root 2. Have you tried finding the value of root 2 on a calculator? You will definitely know that it's not a simple fraction, especially when you get a value which is 1.414213562337 etc. 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 Our aim today is to represent irrational numbers on a number line. The task does seem daunting, doesn't it? But let me tell you, it's quite simple. It can be done by using the Pythagoras theorem. The Pythagoras theorem states that in a right-angled triangle, the hypotenuse squared equals the base squared plus the altitude square. Let's represent such irrational numbers on a number line. Here, we have a horizontal scale fixed onto the board. The vertical scale can be moved freely. The starting point of the scale is marked O. Let us fix a thumbtack with a string at this point. Let's begin by calculating the square root of 2. Let's mark 1 unit on the horizontal scale as P. We will move the vertical ruler to 1 unit. Let's mark this 1 unit on the vertical scale as Q. Let's take the string from point O and extend it to Q on the vertical. Let's make a mark on the thread at the point where the string touches the point Q. This string from O to Q represents the hypotenuse of the right-angled triangle OPQ. Now we will remove the thread from point Q and place it on the horizontal line. The length of the string from point O up to this marked point represents the value of square root 2. Let's call this point as R. In other words, OP square plus PQ square equals OQ square. That is, 1 square plus 1 square equals 2. Therefore, OQ square equals 2. OQ equals the root of 2. Now, we'll calculate root 3. Let's move the vertical scale to point R. We know that the point O to point R represents root 2. Similarly, let's extend the string from point O up to 1 unit on the vertical scale and mark this point Q dash. Mark the thread at the point where it touches the scale. After having done this, we'll now place the string from O on the horizontal scale. Let's measure the length of the string from O to the marked point on the string. Let's mark this point as S. The units from O to S represent the value of root 3. This can be represented as OR equals root 2 and Q dash R equals 1. Therefore, OQ dash square equals root 2 square plus 1 square, which equals 2 plus 1, which equals 3. Hence, OQ dash equals root 3. In this way, we can represent the square root of any natural number on the number line. Let's represent more irrational numbers to make sure we have understood the concept. We'll try and find the square root of 13 using a graph paper. We'll create a right-angled triangle on the graph sheet such that the hypotenuse is root 13. Let us split up 13 into two perfect squares, 9 and 4. We know that the square root of 9 is 3 and that of 4 is 2. Let's represent 3 and 2 as the altitude and base of a right-angled triangle. On the x-axis, mark 2 and on the y-axis, mark 3. Join the points to get the hypotenuse. The hypotenuse represents root 13. In the same way, you can go ahead and find the square roots of any irrational number using graph paper. Just remember to split each number into two perfect squares which will add up to the number. Try it out, it's interesting.